So I'm very interested in the fact, were the data scientists direct users of your platform, or were there also machine learning engineers involved in some way, maybe embedded into the product teams?
Yeah. So there's two answers to that question. One is most of the data scientists. So Mailchimp had a very like engineering. It was a design and engineering heavy culture. So a lot of the data scientists who were there actually had some the most successful data scientists that were there actually had prior experience as like software engineers. So they could, even if the process was a little bit like rough, a lot of times they were able to find ways to kind of like work with it. Um, but in the last like 2-3 years, like Mailchimp had started hiring sort of data scientists that were more like on the product and business side. So they didn't have experience as like software engineers. They need a little bit of help. So each team essentially that was involved in like MLOps or the ML platform initiative had some kind of like what they call like embedded MLOps engineers that were sort of close. They were kind of close to ML engineering role, but not really. Like essentially, they weren't they weren't building the models for data scientists. They were just literally helping with the last mile of productionization. Um, and the way I think of an ML engineer is a full stack data scientist. So you're actually writing up the features, you're also developing the models. So we had folks that were there to help the data scientists get their project like through the process, but they weren't like building the models, right? So our main core users were data scientists, and they were the only ones. But we had folks that would help them out with like answering tickets, answering like Slack questions, helping to like prioritize bugs. And that would be then brought back to like more of like the engineering folks that would work on it. Each team had this kind of mix of people that would focus on like developing new features and tools, and then people that had like 50% of their time was assigned to like helping the data scientist. I think by the time a few months after I had left though, so Intuit had acquired Mailchimp about 6 months before I left. And it usually takes about that long for changes to actually start kicking in. I think what they had done was they had restructured the teams so that a lot of the enablement engineers were on one team, and then the like platform engineers were like on another team. But before, when I was there, each team had a mix of both.
So there were no central ML platform team?
Nope. It was essentially split
Okay.
along training and development, and then serving, and then like monitoring and integrations,
But it's still
effectively.
They were called a platform.
it's still a central platform team, but made up
Yeah.
of
Why are they?
multiple, right?
Yeah.
Multiple streamline teams, kind of part of platform team, probably providing platform capabilities, like in team topologies.
Yeah.
Did they share tech
Mhm.
stack and processes, or each ML team with data scientists, platform, if we can call them like that,
Mhm.
and support people were having their own realm and having own, tech stack, own processes, or you had some initiative to share some basics, you said templates across teams.
Yeah. So So most of the stack was shared. Uh, I think the team topologies, like way of like describing teams and orgs, I think is actually a fantastic. It's a fantastic way to describe it. Because like so essentially like so team topologies, right? There's like four teams, right? There's the streamlined teams, which in this case is like data science and product, right? You have complicated subsystem teams, which are like the Terraform team or like the Kubernetes team. And then you have enablement and platform, I think are like the last two. So each team was a mix of platform and enablement. So for example, the resources that we did share were BigQuery Spanner, like Airflow, right? But what the difference is, and I think this is something that I think a lot of platform teams actually miss. The goal of the platform team isn't always to like own a specific tool or a specific stack layer. The goal of a platform team, a lot of times, if you are so big that you have those specializations, is to piece together not just the existing tool, but occasionally new tools into like a unified experience for your end user. So in this case, for us, it was a data scientist. So for us, even though we shared like BigQuery and Airflow and all that great stuff, other teams were also using those resources as well. But they might not be interested, for example, in deploying machine learning models to production. Like they might not actually be anywhere involved in that aspect. And so what we did was we said, hey, we're going to be essentially your guides to a lot of these like other internal tools. We're going to like create and provide abstractions. And occasionally we'll also bring in tools that we think are necessary. So for example, a tool that was not used, right, by the serving team was like Great Expectations. Like they didn't really touch that because it's something that you would mostly use in like dev and training. You wouldn't really use Great Expectations in production. There were a couple other things too, like kind of not thinking about it right now. Yeah, sorry. I can't think of them all off the top of my head. But there was like 3 or 4 other tools where like the data scientists need to use it in like development and training, but they don't actually need to use it for production. For those, we would like incorporate into like the paths to production. Paths to production. And then in terms of like the serving layer, so essentially the serving layer was like a thin Python client that would take the Docker containers or images that were being used for the models. And then it would essentially expose like the API endpoint so that, for example, teams like upfront could route like any of the requests to like get predictions from the models.
Did you use any pipelining tools, for instance, to allow automatic or semi-automatic retraining of a model, or or data scientists were just training a model, package it into Docker image, and yeah, it was kind of closed?
Yeah, so we had projects that were in various stages of automation. So Airflow was a big tool that we used. That was just the one that is like across the board, everyone in the company uses. So the way we interacted with Airflow was we essentially, as part of like the template. So a lot of times like Airflow, you have to like go and like write your own DAG and create it. A lot of that stuff can actually be automated. And if it's just running like the same type of machine learning pipeline, essentially that was built into like the cookie cutter templating tool. So we said, hey, like when you're setting up your project, you go through a series of like interview questions. Do you need like Airflow? Yes, no. If they mark yes, then essentially that part would get filled out for them with like the relevant information on like the project and all that other stuff. And then it would sub the credentials.
How did they know whether they need it or not?
Yeah, so that is actually something that was part of the work of like optimizing the cookie cutter template. Is like we kind of didn't, like when I got there, essentially data scientists had to like fill out a lot of these questions. Like, do I need Airflow? Do I need XYZ? And for the most part, a lot of times they would have to ask like the enablement engineers almost like, hey, what should I be doing? Like, and sometimes there were projects that needed a little bit more of a design consultation. Like, can we actually support this like model or this system that you're trying to build with like the existing paths that we offer? And then we would kind of like help them figure that out. Then they could kind of go on and like set up the project. It was a pain when they would set up the project and then we'd look at it and go, no, this is wrong. You actually need to do this thing. And they would have to like rerun the project. But something that we did that was like the optimization was saying, hey, just pick a recipe. Like just pick like a pattern, and then we'll just fill out all the configurations for you. And for most of them, like they could figure out pretty easily, like, is this going to be like a batch prediction job where I just need to copy values? Is this going to be like a live service model? Like those two patterns were like pretty easy for them to figure out. And so they could like say, hey, like this is what I want. And then they could just use like the image that was designed for that job. And then once again, like the template process would run. And then they could just fill out like, oh, this is the project name, yada, yada. They did have to fill out like the Python version. Like we would automatically set it to the most stable, like up-to-date version. But if they needed like 3.2 and Python's at 3.11, then they would specify that. But other than that, at that point, ideally, they should be able to do their jobs of like, okay, now we'll like, write the features, we'll develop the models. The other cool part too was we had also been looking at offering them like native like Streamlit support. So that was also a common part of the process as well, where data scientists would create like the initial models, and then they would essentially create a Streamlit dashboard. They would show it to product, and there's this big like Streamlit library, and then essentially product would use that, go like yes, no, and they could then like proceed with that project. And more importantly, if like new product folks wanted to join and they were interested in like what model, like how does this model work, or what models are offered, what capabilities, they could go to that like Streamlit library, or the data science could send them the link to it, and they could go through and like quickly kind of see like, oh, like this is what that model does.